So you just watched a video for the neutralization of stomach acid using milk of magnesia. It's called the MOM demo, milk of magnesia demo, and we're going to look at the reaction that's taking place when you have magnesium hydroxide, which is found in milk of magnesia, and an acid, and then stomach acid is hydrochloric acid. And so we're going to look at what the balanced chemical equation will look like. We're going to write the total ionic equation and the net ionic equation for what's happening in the neutralization reaction of a strong acid and a strong base. So writing balanced equations is back from chapter 8. Writing the total ionic equation and the net ionic equation is something we did in the solution unit. So we have a strong acid, hydrochloric acid, and it's a solution, so its state of matter is aqueous, plus a strong base. We know it's strong because it's a group 2 metal hydroxide, magnesium hydroxide, and it's a solution, it's aqueous. This is a strong acid. And it's a double displacement reaction. We're going to get magnesium chloride. That is aqueous. Chlorides with magnesium are soluble. And in this case, we're not going to get a precipitant like we've talked about before in double displacement reactions. We're going to get water. And so whenever you have a strong acid, strong base reaction, you're always going to get a salt. Magnesium chloride's a salt. It's an ionic compound. And water. These are always the products of a strong acid, strong base neutralization reaction. Now we do need to balance this. I have 2 chlorides on the product side. I need 2 on the reactant side. That gives me 4 hydrogens. So then I need to put the 2 there, and it should be balanced now. So a strong acid plus a strong base always gives us salt and water. What we want to do now is write the total ionic equations. We want to show all the ions that are in solution so that we can identify our spectators and then look at what is actually taking place in this reaction. So hydrochloric acid is hydrogen ions, and there's 2 of them because that coefficient in the front, and chloride ions in solution, and that 2 also goes with the chloride ions. Magnesium hydroxide is magnesium cations, and hydroxide anions, and that subscript of a 2 is not part of the formula for hydroxide. It's telling us that there are 2 hydroxide ions. Magnesium chloride is magnesium cations, and chloride anions. And then water here is a liquid. It does not form ions in solution, so you don't show any ions. You just write it as your 2 molecules of water. So that's the total ionic equation. It shows us all the ions in solution. What I'm going to do now is identify the spectators in this reaction. Spectator ions are the ions that are present, but they're not actually involved in the formation of water for a neutralization reaction. And so they're present, it's an ion present on the reactant side and the product side. So if you notice, I have chloride ions on both sides. So that's one of our spectators. And then I have magnesium ions on both sides. That's the other spectator. So taking that out, I get my net ionic equation. where we have hydrogen ions plus hydroxide ions forming water. And if you notice, there's a 2, the coefficient of 2 is in front of all of those, so I can reduce that. And so when you have an antacid like magnesium hydroxide found in milk of magnesia, and it reacts with hydrochloric acid or stomach acid, what's actually happening in that reaction is that the hydrogen ions from the acid are reacting with the hydroxide ions from the base and forming water. And so this would be your net ionic equation. So if you're given a strong acid, strong base, you should know that the products are salt and water. You should be able to balance the equation, write the total ionic equation, and then remove the spectator ions and write the net ionic equation. If you have questions, I am in room 335. You can stop by before or after school, or you can send me a message in Schoology. Just send the message to Sarah Chapman. Thank you. Have a great day.